Okay, hi everyone. I want to continue our lesson. There's a pressure law. So now we're going to see what means of the pressure law. This one is a definition. Okay, let's see the definition. For the fixed mass, before that I told you the mass must be fixed. After that, the pressure of the gas is directly proportional to the absolute temperature. Means the temperature you must use it in Kelvin unit. Then here is a volume become constant variable. Okay, now we're going to see the situation. Okay, P is directly proportional with the T. T is the absolute temperature. So when we create the formula P1 over T1 equal P2 over T2. Okay, let's see the graph here. We got two types of the graph. When we plot P versus T, then there's the absolute temperature. That's a directly proportional. They will pass through the origin. Okay, if I'm using the temperature here is a degree Celsius, you find it that just increase linearly. So that means when I want to extend the line, they cut the x-axis, there should be negative 273. So the pressure will become the 0. Okay, 0 degrees Celsius, the pressure still not yet 0. They still got readings. Okay, we're going to see some example for the pressure law. Temperature increase, kinetic energy increase. Okay, so after that the collision between the particle and the wall increases. So before that I explained, when collision between the particle and also the wall increase means the pressure increase. So from here the rate of change of momentum. So we're talking about time taken for momentum to change, they produce a pressure also increase. So this one situation example is a tank of the gas. After that is a reservoir. After that we got pressure cooker. Okay, this one solvent, then the pressure cooker. They're using the concept of the pressure law. Okay, now we're going to see the kinetic theory. Okay, this one is a kinetic theory. So that means now we make the volume become constant. So when I heat, so this one is a temperature, increase the temperature. So what happens for the molecule? The molecule will move faster. Kinetic energy increase. When kinetic energy increase, that means the molecule will hit the wall of the container. They're more frequent. When they hit more frequent, that means the pressure of the gas will be increasing. Okay, so this one is a pressure law. So finally, we still need to remember the formula P1 over T1 equal P2 over T2. Remember the T must be absolute temperature. Okay, now we're going to see the kinetic theory, how to explain. First one, the sample of the gas, constant volume. Okay, number two, as the temperature of the gas rises, the molecule moves more rapidly. Okay, as a result, the collision with the wall of the container at higher frequency. The change of the momentum is greater because you move faster, so velocity increase, momentum automatically increase. So that the force that exert on the wall is larger. Finally, the force and hence the pressure increases. Because we follow this formula, when your force increase means your pressure automatically increase. As temperature increases, pressure also increase. Okay, let's see the example 8. Okay, we see the info. A motorist, they blew up her car tires of the pressure 5.4 atmospheric pressure on the cool morning. Okay, so we label this one as a P1. This one is a P1 on a cool morning when the temperature -3. So this one is a T1, temperature 1. Can remember how many to change the -3 become the Kelvin. So you need to plus 273. Okay, what will be the pressure on the tire on a hot day if the temperature becomes 27? Okay, now T2 is 27. Now you need to find what is a P2. So this one is a pressure law. The formula P1 over T1 equal P2 over T2. So all the temperature you convert become Kelvin first. So I show you the answer here. Okay, first one I show you the formula. Okay, number 2 you need to find P2, is it? So P1 is 5.4. Okay, T1 after I minus 3, there's a 270. Then 27 plus 273 becomes 300. finally I get it. The atmospheric pressure is okay, another pressure for a tire, there's a 6 atm. Okay, let's see the example 9. Okay, a cylinder of the oxygen, 27 degrees Celsius. Okay, has a pressure. Okay, this one is a pressure. This one is a T1. Okay, now what is the temperature of the oxygen if the cylinder is cool and the new pressure is 2.7 times 10 power of 6? So that means this one is a P2. This one is a P1. Okay, so another one is this one is a T1. So we do know T2. Okay, now the question they want you to find the T2. So we just apply the same formula lah. So I show you the answer. T1 over P1, T2 over P2. So from here T1 is 273 plus 27. Then over P1, P1 here. Okay, after that we got T2 we do know, P2 we know. Okay, finally I find what's the T2. Okay, I get the T2 is a 273 Kelvin. Okay, if I want to convert become degrees Celsius, actually there's a 0 degrees Celsius. Okay, let's see number 10. A fix of the mass in an enclosed metal container has a pressure. Okay, this one is a P1. Okay, the gas heated from 27 to 87. So this one is a T1. This one is a T2. Okay, now the question they want to find final pressure means they want to know P2. So we just apply it. T1 over T1 equal P2 over T2. So P1 is how many? P1 is 2.5 times 10 power of 5. Okay, then the next one, T1 is 27 plus 273 become 300. Okay, this one is a P2 we don't know. The temperature, final temperature is 273 plus 87. So now they ask you calculate the final pressure of the gas. So we get it 3 times 10 power of 5. Then the unit is Pascal. Okay, now we're going to see the relationship between the pressure and also the temperature of the gas. Okay, let's see the diagram. They show the A pressure of the tire. Okay, being measured on a hot day. Now the driver of the car, they touch about the tire after the journey, and they found that the tire is hotter than before. So after the journey, so you find it, the tire become hot. So now they show the reading of the pressure gauge before and after the journey. So we're going to see the first one. Okay, this one is almost 200 before we start the journey. Okay, after you start the journey, you find it 220. So that means after the journey, the pressure increasing. So this one is one of the situation. Okay, now we're going to see this one situation bring to the experiment. Okay, let's see here inference. Inference, we start with the temperature of the gas. Okay, what we can control? We control the temperature, is it? So from here, the temperature of the gas that influence the pressure of the gas. So the pressure should be the RV lah. Temperature should be the MV. So the higher the temperature, so the higher the gas pressure. So from here, we need to find the relationship between the temperature and also pressure. What should be fixed? The mass and also the volume must be constant. Okay, manipulate variable, temperature, responding pressure, volume, and also the mass is a constant variable. Okay, let's see the apparatus. We need the round bottom flask, large beaker, thermometer, pressure gauge, Bunsen burner. Bunsen burner is together. Bunsen burner, tripod stand, and wire gauge. After that, we got stirrer, retort stand, and wooden block. Okay, now we need the water and also the ice. Ice you want to put is okay, because you want to make the temperature become lower. Okay, let's see the diagram. Okay, the diagram, after you draw, you need to label. Okay, let's see here. Heat the water slowly. Okay, you need to heat and stir continuously until the temperature is reached 30. So if you never put the ice, we cannot put there's a 30. Maybe you put it as a 40 degrees Celsius. There's a room temperature already over 30 degrees Celsius. Now we take the reading from the pressure, from the pressure gauge. Then we go to recorded reading. Then after that, we need to repeat, increasing the temperature 40, 50, 60, 70, and 80. If we start 40, so we repeat 50, 60, 70, and also the 80. Then all the data you must record it inside the table. Okay, so this one is a procedure. Okay, let's see the table. Table, we got two columns, temperature and also air pressure. So when the temperature increasing, you find it the air pressure also increasing. Now we go and see the graph. Again, another graph. P versus the temperature. Using absolute temperature, there's a pass-through origin. So if now I still using degree Celsius, you find it the graph is increase linearly. So when you extend the line, you cut at the behind there, you find this one is a negative 273 degrees Celsius. Means there's a zero Kelvin, absolute zero. Okay, so this one is a conclusion about what we learned about the gas law. Okay, first one, this one is a pressure law. Volume constant, so we go to close the volume. So you find the formula is a P1 over T1, P2 over T2. Okay, second one is a Boyle's law. Boyle's law is a temperature constant. So temperature constant, we just close the T lah. So we find the formula P and V side by side. So this one is a P1 V1 equal P2 V2. Okay, last one is a Charles law. Charles law is pressure constant. So we go to close the pressure. So now the formula is a V1 over T1 equal V2 over T2. This one is the overall. What's the formula you need to know? Boyle's law, Charles law, and pressure law. Okay, one more important note. The temperature must at 273. To show the calculation. So this one is example 1. You see the syringe V1 60. Pressure 1 is a 108 kilopascal. Now the piston string is push, compress. The volume becomes 48. So 48 should be the V2. Okay. Sorry, there's a 48, not 40. Coming to change, there's a 48. Okay, so from here, calculate the pressure of the compressed A. So that means P2 is after compress. So we need to do the calculation. Okay, let's see the calculation. Okay, P1, V1, P2, V2. This one nothing is about the temperature. We no need to see about the temperature because they never mentioned. So we assume there's a constant. So this one is a Boyle's law. 108 multiply 60. Then P2 we do know. V2 is a 48. So after that we find it there's a 135. Follow the unit of the question, kilopascal. So we just write kilopascal. Okay, let's see the second one. The A bubble has volume. They show you the volume 1.2. Temperature 27. So this one is related with the temperature. So there's a not Boyle's law. Okay, now we're going to see the volumes of volume and temperature. Suppose there's a Charles law. Now another situation, the volume of the A bubble if the temperature increase until 47. So they want to find V2. So the info, V1 1.2, T1, remember plus 273. Then the T2 also plus 273. Last one you need to find volume 2. So we apply the formula for Charles law. So you get it, the result is V2 is 1.28 cm cube. Okay, when the temperature increase, volume also increase. So now we go to the number 3. Okay, gas is a closed steel cylinder that has the pressure of the P1, 180 kilopascal, temperature 25. So Pascal pressure and also the temperature. So this one should be the pressure law. So what is the gas pressure when the cylinder heated? Temperature becomes 52. So you need to find is a P2. Okay, let's see the info. P1, 180. T1, 25 plus 273. T2, 52 plus 273. P2, we do know. So we apply pressure law formula. Okay, you want to find P2, is it? So 180 over 298. 298 is a T2. After that, multiply with the T1. This one 180 is P1, pressure 1. Then T1 should be temperature 1. Multiply with the temperature 2, there's a 325. Final answer 196.3 kilopascal. So this one is another example. The A bubble at the bottom, okay, there's a 4, the volume is a 4 mm cube. What's the depth? The depth is a 5 meter. This one is a surface. So surface, we got atmospheric pressure only. We will find the depth. That means you need to find the pressure for the bubble. There's a atmospheric pressure plus the depth pressure. That one we call P2. Okay, so from here I show you the equation. This one is a Boyle's law. P1 V1, P2 V2. So P1 is how many? P1 is the bottom one. So they take 10 atmospheric pressure plus the 5 meter. So this one is a 10 meter of water plus 5 meter of water, then become 15. Then V is a 4. Then P2 is a surface. So surface should be the 10. Then V2 we don't know. So the final answer is a 6. When pressure become less, your volume become bigger. Okay, let's see the second one. A cylinder of the volume 0.2 L. Okay, 0.2 L. Then after that, contain the mixture of the A bacterial atmospheric pressure at the temperature 25 degrees Celsius. So this one's a volume, this one's a temperature, so this one should be the Charles law. Now the gas is expanded by pulling the piston until the volume become 0.25. So under the constant pressure, so find the new temperature. So normally new temperature they want to count in Celsius. So after you calculation you get Kelvin, you go to minus. Okay, so this one is a formula. 0.2 over 27 plus 273, then equal 0.25 over T2. So I get a T2 is a 372.5 Kelvin after minus 99.5 degrees Celsius. Okay, let's see here. This one is a Charles law. Okay, the volume can be expanded. Okay, this one diagram that shows the trapped gas being heated in the enclosed space. Now you need to using the kinetic theory molecule to explain why the volume increases when the temperature of the A increase. So that means when the temperature increase, that means you go to heat. After you heat, kinetic energy sure will be increased. So that means now the molecule, they will move faster. When they move faster, they will collide to each other. When they collide to each other, means they will expand. Okay, they will expand. Finally, the gas inside there, they got high pressure. So they got high pressure. When they just expand the volume up, that means they will up until the certain level, the pressure become constant. So they will stop it. So this one is a kinetic theory of molecule. So from here, the temperature increase, kinetic energy increase. Collision between the molecule increase, thus volume will increases. Okay, the next one, a gas of the volume 35. So this one is a V1, temperature 40. So V and T, so this one is a Charles law. Okay, fixed pressure. When I mention fixed pressure, we know there's a Charles law. Now the volume we do know, the temperature becomes 70. Okay, remember temperature in Kelvin. So I show you the answer here is 35 over 40 plus 273. Then V2 we do know. Then the T2 is 70 plus 273. So I get it, the V2 is 38.35. So we just follow the unit lah, meter cube. Okay, now we go to the pressure some oxygen, 1.5 atmospheric pressure. So this one we know lah, pressure. Then increase to 27 atmospheric. So P1 1.5, P2 2.7. Initial temperature. So that means this one is a pressure law. Okay, temperature and pressure. So temperature now is a 12 degrees Celsius. So you need to convert become Kelvin. Now they ask you what is a final, means the T2 that you know. So we just apply P1 over T1 equal P2 over T2. 1.5 over T1 is a 12 plus 273. After that, the 2.7 is P2 over T2. So I get it, the answer is 513 Kelvin. So how to get degrees Celsius? You just go to minus 273. There's a 240 degrees Celsius. Okay, now you see the apparatus. They used to investigate the relationship between the pressure and also the temperature. So there's a pressure law. So now by using the kinetic theory again, explain why the reading X increases. Okay, reading X means the button gauge, there's a pressure. How come the pressure can be increased? So we're talking again, when you hit, kinetic energy increase. Kinetic energy increase means the collision increasing. Collision between the wall container increases. Finally, they will increase the pressure. Okay, let's see the answer. Kinetic energy, speed, A molecule increase. Frequency collision between the A molecule and wall of the flask container increase. Rate of change of molecule also increase. Finally, pressure increase. The motorists, they blow up the motorcycle tire. Okay, pressure they give you. This one is a P1. In a cool morning with the temperature 15. So what is the pressure of the tires on a hot day? 37. So this one is a pressure law. We just apply. Okay, so 2.7 is a P1 over T1, 15 plus 273. P2 we don't know. Then T2 you just plus 273. Final answer 2.91 times 10 power 5 Pascal. Okay, now we're going to see this part. Okay, I want to show is an answer of the tutorial. There's a 4.4 gas law. Hopefully you are finished it. So I just show here. Okay, please check. I think the number 6 and number 11 you cannot see, is it? So I just mentioned here lah. So I write here. Okay, number 6. Better using other colors lah. Number 6. Okay, number 6, the answer is donkey. Yeah, I just show here. Number 6 is donkey. Then the another 11. I think the question got 2 11, is it? Okay, first 11 there's a A. The second 11 also donkey. Okay, so this one should be the answer. So you check the answer first. After that, you still don't understand why the answer like this. So you can PM me. You can snap the photo. After that, you ask me about the calculation. I will show you there. Okay, through Telegram. Okay. Okay, our lesson just until here. Hopefully you understand. For the